Okay, welcome back to the review. This is chapter 6 review for sections 6.1 through 6.3 and also 6.5. And we are doing number 21 here, which wants us to use the given factor to completely factor that polynomial there. So we're going to take the information that x minus 5 is a factor and take advantage of that. And you can see I've got synthetic division set up here. Copy your 3, multiply by 5. Add, multiply by 5. Add, multiply by 5. And what's nice about this is that 0 is a welcome and expected friend. We were told that it was a factor, x minus 5. And that means we should get 0 there. Okay, now you back up and put your variables in. And at this point, we're going to put the star into action. 3 on the wings, that comes from the leading coefficient. Then you multiply those, you get negative 12. And the number in the middle is 4, positive 4. I'm going to make it a little more obvious that it's positive 4. We need two numbers that multiply to give negative 12 and add to give positive 4. And I think 6 and 2 has potential. If we make that the negative, I think it's going to work. The fraction on the left is 1/2. And so when you turn that sideways, 1x plus 2, you get your first factor. On the other side, we have a 3x minus 2 showing through the clouds here. And that is not the right answer yet because you have to also include the given factor. So we're going to add x minus 5 to the end there. And we've got our expression factored. Okay, so don't forget the given one. It's easy to forget that, the one that was given to you for free, you didn't invest much in, so it's easy to forget it. Okay, what we're supposed to do on this one is find the value of p of negative 4. In other words, what would you get if you put a negative 4 into all of those x value locations? And we're going to do it it tells us we have to do it with synthetic division. Well, this is normally written p of x. You can actually see that over here. And what that means is that the pocket value there is actually the x value. And that means it's ready to plug in over here. So you don't need to change anything when you plug that one in. All right, the 3 copies multiplied by negative 4. Add, multiply by negative 4. Add, let's see, this is going to be 108. And multiply by negative 4. So negative 4, let me make sure I'm doing this right here on the calculator. 108 times negative 4. Negative 432. So we're going to add again. And when you add those last two numbers, you get negative 450. Now, for comparison, you can do this just verbatim. P of negative 4, we should get the same answer here. I'm going to go ahead and write it before I go any further here. P of negative 4, if we've done everything right, is negative 450. Okay, so let's just stick it in just to compare. And we'll cube that. Minus 12 times the negative 4 squared. And then plus 12 times negative 4. And then we have a minus 18 tacked on the end there. So give me a second to type all that. And we'll soon confirm whether this answer is right or wrong. It does equal negative 450. So this is the answer, and we did it the way that was specified by using synthetic division. That's called the remainder theorem because your answer is in the remainder box. Okay, so there we go. And give me a second to set up this next one here. So we're supposed to use the rational root theorem to list all of the possible rational roots. I'm going to call them zeros instead. Possible rational zeros. PRZ list is what's being asked here. So if you remember, the PRZ list, possible rational zeros, in other words, we're going to make an answer bank. Which numbers might work to zero out that function? So you take the factors of the back number, the constant, which in this case are positive and negative 1, positive and negative 2, positive and negative 3, and positive and negative 6. You can just put the plus and minus sign in front. And then you put that over the factors of the front number, which are 1, 2, and 4. And combinations of the four numerators that are up there, there's really 8 of them because of the positive and negative, over the denominator possibilities, which are 1, 2, and 4, is what we're looking for. So we're going to start, I always want to start with using that denominator first. So 1 over 1, 2 over 1, 3 over 1, and 6 over 1 just gives that list right back. And then you use the next denominator, so 1 over 2, 2 over 2, and so forth. 1 over 2. Now when you get to 2 over 2, it's already listed, so you don't list it. 3 over 2 would be the next one. When you get to 6 over 2, it's already listed, so don't list that one. And finally, you're going to use up this last denominator, so you get 1 over 4. 2 over 4 is already in the list. 3 over 4 we have to write down. But 6 over 4 is this 3/2, so it's already listed. And we've got our part A, our possible rational roots. Okay, so how do you decide which ones of those numbers, and there's a total of 16 in there if you count both the positive and negative versions, how do you decide whether they're roots or not, actual rational zeros? What you're going to do is you're going to graph the function and find out where it crosses the x-axis looking for rational answers. So let me go to my calculator. And once I'm there, I'm going to go to my y equals key, and I'm going to type in 4x cubed, x to the fourth, plus x cubed, plus 5x squared, plus 2x, and minus 6. So I got the function typed in. I'm going to hit the zoom key and choose choice number 6 for zoom standard. So here's the screen. And I'm worried that I'm only seeing 2 answers here, but maybe there's only 2. Let's go ahead and let me zoom out a bit here. I'm going to zoom number 3 and take a wider view. Yeah, those are the only 2. So I'm going to go back to zoom 6. And here we go. All right, so I actually think that -1 is one of the answers. It looks like it crosses the x-axis there. So I'm just going to hit the trace key, type -1, and once I get that trace key activated, okay. If you give me a second, it looks like my thing is frozen up, so let me regraph it. Okay, I'm back. Hit the trace key and hit -1 to see if it zeroes out. And it does, so there's your first root. And your next one looks like it's between 0 and 1, or even 0 and 2. And I'm going to use those as my left and right bound. So go second, and then above the trace key where it says calc, and you want to then go down to the second choice. And when it asks for a left bound, use 0 on the left and 1 or 2 on the right. Let's use 2. And then between those values, it's going to find that x-intercept there, which is 3/4. So we had -1 and positive 3/4. -1 and positive 3/4. Those are the rational roots. Now, because this has got a fourth power, you know there's 4 answers. The remaining two answers must be either irrational or imaginary. Okay, we're going to do one more like this. We're going to do the factors of 16 first on top. 1, 2, 4, 8, and 16. And then they're positive and negative versions. And then the factors of 3 are 1 and 3. Okay, so if you take this denominator here, you get your numbers back. So dividing by 1. And then you keep going with the 3 underneath, 1/3, 2/3, 4/3, and so on. Okay, now that's part A. There's your possible rational zeros list is what it's called. And I'm going to go now to the calculator. Not seeing it, so let me launch it again. Okay, give me a second here. All right, we're ready to go. I'm going to clear out the old formula. So I go to my y equals key and hit clear. And now I'm going to type in the new one. 3x cubed minus 8x squared minus 20x plus 16, and I'll graph it by hitting zoom 6. Now the two that I think I can probably guess, it looks like it hits at -2 and at +4. So I'll hit trace 2, enter, and that wasn't right. Okay. Oh, -2, no wonder. -2, enter, and that did work, okay? And then I think 4 works, so I've already hit trace, so I'll just hit 4, enter here. And that one also works. But there's also the third one. It's between 0 and 1. So I got to find it going second and above the trace key where it says calc, choice number 2. And I'm going to isolate that answer between 0 and 1, 0 on the left, 1 on the right, and hit enter again, and it jumps to 2/3. So -2, 2/3, and 4 are the answers. And so let me go back to my paper here. -2, 2/3, and 4. Those are the three answers to that problem. Okay, so that does it for problems number 21 through 24.